Okay, guys, so this is the last set of notes that we have for solving quadratics, and this method is called completing the square. You can see right at the top of the notes. It's my least favorite. I don't really know why I don't love this one. I don't know. I just don't really feel it. If we don't feel like using the quadratic formula, which we always should, because why? Because it works every time. Then we can complete the square, meaning we can give the equation a new c value so that it is factorable. Looking at this right now, I cannot think of any ways to factor multiplying to negative 18 and adding to negative 10. Just 9 and 2, 18 and 1, it's just not going to happen. So we can switch out the negative 18 for something else so that we can factor it. But there are some constraints here. There are some exceptions to using completing the square. If you have a number bigger than 1 in your a value, so if you don't have a naked variable, if you have a coefficient here, as well as if your b value is an odd number, then completing the square won't work. You've got to have a naked variable. You've got to have an even b value. Doesn't matter if it's positive or negative, but it's got to be even, because part of this whole thing, as you can see if you look down, is dividing b by 2. And you can't get a decimal. So again, one of those methods, just like graphing and factoring, that will not work every time. But if you are looking at your given equation and you can't factor it right off the bat, like if it takes you like more than 60 seconds to try and factor it, then see if you've got a naked variable, and if you've got an even b, then we can go ahead and do complete the square if you like hate quadratic formula that much, which I don't know why. Okay, so let's dive in. There's a lot of steps here, and it's going to seem confusing, but when you kind of step back and look at it, you're just going to say, oh, I get it, right? Right? All right, x squared minus 10x minus 18 equals 0. We cannot factor this as is, so we're going to ditch 18 over to the other side and get a new c value in here that we can factor. So I'll have x squared minus 10x, leave that space, and I've moved 18 to the other side by doing the inverse operation. So I've added 18, which gives me a positive 18 on this side. And now I've got to fill something in here. So what am I going to put there? I am going to create our new c value by dividing b in half and squaring it. So if b is negative 10, what's half of negative 10? What's negative 10 divided by 2? It's negative 5, right? Negative 10 divided by 2 is negative 5. And then I need to square that. So what's negative 5 squared? It's 25. So I am going to fill that in on both sides. I'll have x squared minus 10x plus 25 equals 18, squeeze it in, plus 25. Okay, and what's 18 plus 25? 43. All right, so I'm going to rewrite that just so it's a little bit neater. X squared minus 10x, those things don't change, plus 25 equals 43. Okay, now here comes my factoring part. I can factor this, right? What multiplies to 5, or I'm sorry, what multiplies to 25 and adds to negative 10? It's 5, right? Negative 5. Negative 5 times negative 5 is 25. Negative 5 plus negative 5 is negative 10. Now there's a shortcut to getting to that answer, and that shortcut is you take your b value and you divide it in half, and instead of writing it as we normally would, like x minus 5 and x minus 5, we're going to write it as a binomial squared. X minus 5 squared, which is the same thing as expanding it. Okay, so I took negative 10, divided it in half to get negative 5, and I write it as a binomial squared, x minus 5 squared, which is also just the square root of 25, but we have to watch for the sign. So don't base it off c, base it off of b so that you can make sure you have the correct sign. B divided by 2 is going to be negative 5 squared equals 43. We don't have to do anything with x minus 5 squared on this side of the equation because we weren't changing the value of this side of the equation in any way. We weren't adding or subtracting anything from it. We were just rewriting it kind of in a shorthand. So we don't have to do anything on this side. The equality properties do not apply when we're just rewriting. Okay. Now we're going to square root both sides. So the square root of x minus 5 squared equals the positive or negative square root of 43. When we're square rooting a number like this, we're going to write a plus and a minus in front of it because there are going to be two solutions here, right? We're dealing with a quadratic, so we know we're going to have at the most two solutions, and one will be positive and one will be negative. Now remember, when we're talking about solving equations, if I wanted to move my negative 18 to the other side, I did so using the inverse operation. A negative 18 will adding 18 would be the opposite operation. And this is no different. If I want to get rid of this square, then I do the opposite operation by square rooting it. And square rooting that square will wind up giving me x minus 5 because it's just going to make that square disappear, and then the radical disappears as well. And there is no simplification to the square root of 43, so that will stay in the house. I'm looking for the x value here, so I need to get it by itself. I need to get this 5 on the other side. I'm going to add 5 and add 5, and my solutions will be 5 plus or minus the square root of 43. Well, wait, Ms. Thompson, I thought we were supposed to get two solutions. You have two solutions here. This plus or minus is indicative of two solutions. You have 5 plus the square root of 43, and you have 5 minus the square root of 43. This is a prime example as to why graphing and factoring does not always work. There's no way you could see this as a solution in the table of a graph or be able to factor to get this as one of the factors, okay? So we changed this original equation into something that was factorable, but by proceeding through the factoring and getting the value for x, we wound up with an imaginary number, which is totally fine. There's a spot on the x-axis for that. It's just not going to show up in your calculator in the table. All right, that doesn't mean it's wrong. Let's try a couple more examples. All right. X squared plus 8x minus 20. 10, we're going to move this 20 to the other side. And in its place, we are going to rewrite a new c value that is going to be 1/2 of the b value squared. What is 1/2 of 8? You're right, it's 4. What's 4 squared? 4 times 4? It's 16. Plus 16. All right. So how can I rewrite this as a binomial squared? I'm going to take half of b, which is 4. X plus 4 is my binomial, and I'm going to square it. And then I'll combine my like terms on this side and get 36. Oh, this is going to be exciting because 36 is a perfect square. It's going to work out beautifully. I'm going to square this whole thing. X plus 4, I'm going to square root the whole thing. So much square. Plus or minus the square root of 36, which means x plus 4 equals positive or negative 6. So if I move my 4 to the other side, that gives me x equals negative 4 plus 6 or negative 4 minus 6. So x equals, well, I'm off the page. There we go. Negative 4 plus 6, that gives me a positive 2. Negative 4 minus 6 gives me a negative 10. These are my two solutions. Now, these are nice whole numbers because we have figured that out by factoring. Absolutely. I can look here and say, well, how can I multiply to negative 20 and add to 8? Well, it's positive 10 and negative 2. But then, had I done that, I would have had x minus 2 and x plus 10. I would have had to set them equal to 0 to wind up with x equals 2 and x equals negative 10, which is exactly what we got. We just used completing the square to get there. No biggie. That's what practice is for. I'm not going to dock you points because you used a more complicated version of solving. All right, let's try this one. We're going to move the 63 over, and we're going to create our new c value by doing half of b and squaring it. So what is 1/2 of b? 1/2 of 2 is 1, and 1 squared is 1. And add 1 to the other side. Now I'm going to rewrite this as my binomial squared, meaning I'm going to take 1/2 of b, x plus 1, which is also the square root of c. Square that, combine my like terms, and I get 64. Since this very obviously is a perfect square, this is going to work out with whole numbers as well. So this is one that we could have factored 9 and 7. But this is good practice. All right, so we're going to square root the whole thing. Square root of 64. And if you guys know anything about me, you know that 64 is my favorite perfect square. X plus 1 equals positive or negative 8. I'm going to get rid of this one, which means I've got x equals negative 1 plus 8 and negative 1 minus 8. So my solutions, negative 1 plus 8 is 7. Negative 1 minus 8, negative 9. Again, we could have done this by factoring, but it's great practice using kind of a simpler set of numbers for completing the square. That way, when you get to one of these wackadoodle problems where you've got either imaginary numbers or unsimplifiable radicals, you're not so weirded out. All right. Fairly simple. You just have to remember the steps. You have to remember when to use b minus 2 squared, or b divided by 2 squared, and when to use x plus b divided by 2 squared. So just make sure you are following along with the notes when you try your examples in class. Write down any questions that you have, and we'll get right to it with some practice before our unit test. All right, guys, great job.